Might watch it, I doubt it. Yeah. Yes, we did. Yep. This is pre-calc 2.0.
Okay, I forgot he is. He is just from Zach.
Nope.
I thought about taking that class. Yeah, who decided that? Jared, I guess. I thought about taking too, but I was like, I'll take a college class instead. Yeah, I'll be able to finish now.
Yeah. I made a green print yesterday. Okay. So, when do oblique asymptotes occur? I talked about it. Yeah, so when we did the horizontal asymptotes, we had those three cases. Our third case was when A was greater than B. So basically the degree of the numerator greater than the degree of the denominator. So we said there was no horizontal asymptote. It was a slant asymptote. So if I know it's a slant asymptote, basically I have a line that's angled in some shape or form or whatever. So basically I need to figure out the equation of this line. Most times we write equations of lines in what form? Yeah, y equals mx plus b, so it's going to be its slope-intercept form. Okay. So, for example, if I had a degree larger than the numerator, so I can have like x to the third plus 1 over x squared plus 1. Right? So this would be an example where the degree of the numerator is larger than the denominator. Anybody remember or take a guess on how we found this asymptote? We have to do long division. Maybe there's an instant for review. Synthetic division. I want to say it's not every time. Why can we only use synthetic division? There's only one case. Yeah, so it has to be a first power polynomial. And I would think the denominator is always going to be a first power polynomial. Could be. Not always. So, yay. Bringing it back. Okay, so lucky for you, the denominator is a first degree polynomial. Oh, jeez. We're losing it over here. Oh my gosh. So I was looking to see if any of them were, like, you'd have to do long division. No. So let's do synthetic division since we should be at that. It's easier anyways. So what number goes in the box? 2. So I would set the denominator equal to 0, solve it, that number goes into the box. Then what are my coefficients? 1, 0, 1. And that comes from the numerator, coefficient of x squared. Then I have an x here, so I have 0, and then 1 is the constant. So 1, 2, 3, 4, 5. Okay. So how would I write this 1, 2, 5 thing as a polynomial? x minus 2. Yeah. So if I actually divided my rational function, this is what I get out. Okay? But I'm only taking a part of that because I can't graph this like 5 over x plus 2. So our slant asymptote is just the line y equals x plus 2. And that comes from just the function without the remainder. Okay? So that's slant asymptote. I could find the vertical asymptote as well. And how do we find vertical? Set denominator equals 0. So it's x equals 2. And since we have a slant, we won't have a horizontal. So don't need to worry about that. So you identify the equations of the asymptotes. So now I can graph my asymptotes and then plot some points. So x equals 2 is the vertical line. Not that too shabby. We should all hopefully remember how to graph the line. So start with y-intercept of 2. Then your slope is 1, so you rise 1. 1. And I'm making points so we can connect it. Oh gosh. My graph is going to go all over the place here. Okay, so basically my situation is what I'm noticing. So I have it cut into 4 quadrants. So either my graph is going to be like in this piece that I don't really have a lot of space for, and down here, or in the larger area. So it always has to be an opposite quadrant. So we just have to figure out where they are by plugging in values for x. Okay. So what do you want to plug in for x? 2. Zero gets out. So yeah, definitely in the quadrant that I don't have enough space for. Fantastic. Okay, let's do like 1 and negative 1. So then we're gonna have to pick points on the right side of 2. I feel like we should all do 1 again like we did yesterday. Lisa chose 1. Millie's doing negative 1. Kayla. Haley. And Maddie got negative 5, like yesterday. Oh my gosh, guys, you have to start over. Whoever did the negative 3, you guys should copy. It needs to be positive. I'm sorry.
Negative 1 is 2 over negative 3.
Yeah, because negative 2, negative 4 are not on the right side of the vertical asymptote. Yeah. Okay.
So I got 10.
Okay.
So now it's good.
It sounds right. It's better than the negative because I like negative. Okay. Amelia, what did you say yours was?
This is negative 4. I got 8.
Those sound different. Okay, I don't agree with -4. Now that I graphed it, it doesn't look right. Should it be?
Is it too big either?
Yeah. It just looks weird, like it's too far down. So then we're approaching our asymptotes. So something like that. Make sure you cross and lovely. And then my graph from the other spot is going to be up in the millions in here. Yeah, I kind of went over. Okay. So like that ish. My asymptotes would not run into my synthetic division here. That'd look nicer. Yep. Let's show this. Okay. Well, that is our one and only problem that we're choosing. Nice.
And then that was our only problem. I put down over.
Great. Well, I was, definitely not expecting it to look like that because I would have had it. It happens.